Come on, go live. We are live. There we go. Okay. So we were just playing around with number 3 here, and we were asked to take that 10.99% and turn it into a monthly rate. So we divided by 12. And that gave us the 0.92 to 2 decimal places. Now that's 2 places of a percentage. So this right here is to the nearest hundredth of a percent. Okay, the 9 is the 10th of a percent. So let's make a note of that just to get used to those facts, because most of us don't see those daily. So that 2 right there is 100th of a percent. 100th of a percent. And that 9 is in the 10th position. It's still a percentage. We never dealt with that. So that 9 is a 10th of a percent. For most calculations I think usually taking percentages to the nearest 10th is good enough. But this one started to the nearest hundredth. So the bank, when they do their calculations, they're going to do them out to the nearest hundredth also. Okay, so usually you stick with whatever you start with. All right. So part 4 asked us to say, all right, let's suppose that we have a $5,000 balance, which we had written just a moment ago. And again, we now have a monthly percentage rate that is approximately 0.92%. And mental note, that's about 1%. If we want to know what happens in January here, then the simple interest formula says, well, January is 1 month, so you apply the monthly periodic rate. So we want to know about what's due in January. And just pay attention in the worksheet. Sometimes the worksheet says, hey, just approximate, estimate the amount. So in parts A and B here, we're estimating. And then down here in parts C and D, we'll actually make the real calculation, something that would appear like on a credit card statement. So just estimating. So for me, my estimate would go something like this. 1% is 1 out of 100. Okay. So for every $100, I owe $1. Question is, how many hundreds are in 5,000? Well, if I divide out the 100, what's left is a 50. So I think what is due is about $50 in interest. So I think the interest amount is about $50. For January. When banks do these calculations, they actually take into account how many days are in a year, so they'll get slightly different numbers, but it's going to be about 50 in our estimation. So in the next part, we're asked to think about what if she maintains that $5,000 balance? So she spent a bunch of money, she spends, let's say she spends money each month and she pays off a little each month, but on average, she's still stuck with about $5,000 in debt. How much will she end up paying over a year? Okay, so there's a couple of different ways to estimate that. One way is to just take the previous example that said, hey, we got 50 bucks in 1 month. What's going to happen in 12 months? Well, that would be 50 12s. So one possible estimate for that over a year. So part 1, I could say, well, I know it's 50 bucks in January, there's 12 months in a year. 12 times 50. It's more than 500. What is it? 600 maybe? Sound good to anybody? You guys can speak up over there in Pendleton if you want. I know Emily's dying to say something. Yeah, it's different when you have a talking voice on the computer. Sorry, you guys. All right. So other way I might think about it is the interest rate was 10.99%. I could say, that's about 10%. Okay. 10% is 10 out of 100, or 1 out of 10. So I want to know what's 10% of 5,000. So how many tens are in 5,000? Well, if you divide it in, that's going to get rid of a zero. So the interest is about 500. And my thinking for this here was, this is kind of an overestimate because I rounded up when I divided by 12, and this is an underestimate because I dropped down to 10% from 10.99. So the actual amount I owe is going to be somewhere between 500 and 600 over a year, if my debt is 5,000 and my APR is 10.99%. Okay. So an explanation, it asks for an explanation of your strategy. Show some work or write me a sentence there. Right. Okay, let's move on. So Brian is not as lucky as Juanita, because Brian has a bad credit score. Brian has a bad credit score. That implies he's going to be stuck with a 23.99% APR. So let's calculate his monthly rate. What is that going to be? So Brian's monthly percentage rate, I'll abbreviate as MPR, right? M is for month, is going to be that 23.99% divided by 12. Whip out a calculator. I think it's going to be around 2% roughly. So, and again, the instructions are usually, since we started with 2 decimal places in the percentage, we'll end with 2 decimal places. If you round that 9 up, it's going to bump everything. So it's pretty darn close to 2.0%. So when I round to 2 decimal places, I do indeed come up with about 2.00%. And I'm going to put those O's in to indicate, yeah, I believe I'm accurate to that spot when I round it. So we haven't done anything to deal with the percentages. It is still a percentage. So we're just going to leave it that way for now. And now he has a balance of 5,000 also. And in the simple interest formula, that's usually a P, like I showed earlier. So a couple ways to think about that. Well, we know that 1% would have been 1 out of 100, and there were 50 hundreds in 5,000. Aren't we doubling that here? Yeah. So instead of $50 a month being owed, I would say it was about $100 a month would be my estimate. So my reasoning, and we're asked to actually calculate it here instead of estimate it. So to actually calculate it, interest is equal to the balance, P, times the rate, times the time. My balance is $5,000. My rate is 2%. I'm going to write that as a decimal. 0.02 would be that as a decimal. Now, what kind of rate is that again? An annual rate or a monthly rate?
Monthly.
Yeah, it's a monthly rate. And the key thing about using this simple interest formula, whatever the period is for the rate, it's got to match for the time. So since that's a monthly rate, I multiply by the number of months. Well, this is just 1 month for this particular part. And so if you calculate that out, I'm pretty darn sure that comes out to $100. Did anyone double check with their calculator on that? Okay. So that one we were actually asked to calculate. The previous two we were just asked to estimate. And then Brian maintains this balance for a whole year. Calculate how much for the whole year. Well, the difference there is that the time, instead of having 1 month, is going to be 12 months. Okay. So for, let's see, this was 4C. For 4D, I'm going to do that same thing, but for 12 months. So the interest is going to be that 5,000. And a habit I'd like you to get into is anytime you whip out your calculator to do something, write down what you told your calculator to do. So on paper, I write down 5,000 times 2 hundredths times 12, and then I whip out my calculator, and my calculator should tell me that's 1,200 for that one there. Okay, so before I turn the page, too late, I already turned it, I'm going to do two spreadsheets with you. And so I'm going to do one spreadsheet based on the Brian and on Juanita, but I'm going to use some different numbers there just to redo those calculations to get used to it, because this is definitely going to be on the test. And then we'll also make this spreadsheet here. So what we're going to try and do in a little bit is recreate this spreadsheet, and for interest paid, we're going to try to enter the formula that they give here. Okay? And I'm going to do that formula in a couple of different ways. And so for those of you in Pendleton watching, if you happen to have a computer, give it a shot live. Otherwise, we'll end a little bit early today. You could go to the computer lab and try. And then anyone that had trouble, I'll help later with that. I'll be around later today, and I'll be around, most likely I'll be around tomorrow. I caught a new cold from a relative this weekend, and I'm not feeling so hot at the moment. My apologies. Hopefully I'll be well enough tomorrow. Okay, so before we do this one right here, we're going to make a spreadsheet based on the work we just did with Juanita and Brian. And so I need a spreadsheet. And so I'm going to do a couple of different things here. Run this time, please. Let's blow this up so you all can see. Hopefully that's big enough. All right, so I'm going to put myself in this spreadsheet, and I'm going to put my daughter Ruby, who is trying to be financially responsible these days. And we're going to have an annual percentage rate to deal with, APR. Based on that APR, we're going to have to calculate an MPR, a monthly rate. And then for fun, we're going to calculate a daily percentage rate too. Okay. And so I'm just going to make a note on the side. That's yearly. This one is monthly. And this one is daily. All right. So Gary is good at math, but he is not good with time. And so there were a couple of recent medical bills that he did not pay on time, and those medical companies, they turn you in immediately. So as a result of that, Gary doesn't have the best credit. It's not bad, but it's not great. So Gary has an interest rate of 16.99%. Ruby is a young person with new credit. She's got a checking account, and she has no marks against her, but she doesn't have a lot of credit. However, since she's about to be a college student, banks are usually pretty generous in giving credit cards to college students. So she has a better rate, and Ruby's credit rate is 8.95%. Ruby got a better deal than her father. All right, so what I want to do is then we're going to play around with just what are the monthly and daily rates. So to do that, again, remember anytime, oh, I should give this a name. Let's see, we will call this personal finance. So to do a formula, I go to a cell to put it in, and I always type equals. And what I want to do is I want to change the APR to a monthly rate. And earlier to do that, we divided by 12 is the simplest way to do that. So I'm just going to click on that percentage rate above and divide by 12. Now, it's not currently displayed as a percentage, so I'm going to say, hey, computer, give me that as a percentage. And the default in most spreadsheets, Excel and Google Sheets, is to give you 2 decimal places of the percent, which is cool because that's what this project and most banks do. So he's going to pay about 1.5% per month on whatever his balance is. As far as the daily rate goes, there's a couple of ways I could do that. I could take the monthly rate and divide by what? Maybe 30, because it's about 30 days in a month. So that'd be one way to do it. Or I could take the yearly rate and divide by 365. Okay, so a couple different options. Will they be exactly the same answer? The answer is no, they won't be the same. So I'll do it both ways just to see what happens. So first I'm going to take the APR, divide that by 365. And I get a very small fractional amount. And the banks they're going to pay attention to most of those decimals. Okay, even though they might display on the credit card disclosure only two decimal places to the nearest hundredth of a percent, they're going to use a bunch more when they do the calculations. So if I convert this to a percent, it's going to say, it's about a half of a hundredth, half of a tenth of a percent, right? 500% is what that comes out to be. So I'm going to put that back the way it was for a sec. And we're just going to do it the other way I mentioned. What if I took the monthly rate and divided by 30? Will I get a much different answer? And yeah, it's a little bit different, right? 465, 4712-ish. But you know, it's in the ballpark there. Okay. So this is a regular decimal. Counting over, that's the first two are regular percentages, and then this would be a tenth of a percent. That 4 is in the hundredth of a percent position. And you can see that when I tell the computer to change those to the nearest hundredth of a percent, it doesn't really matter which way I do it. It's about the same, okay? And anytime you do a calculation, you're gonna end up rounding, which means estimation is involved. So I'm just gonna repeat those for Ruby. Equals, take Ruby's rate, divide by 12 to get our monthly rate. Equals, I'm going to take the yearly rate and I'm going to divide by 365. And then I'm going to tell the spreadsheet by highlighting them. Remember, to highlight stuff, you click in the middle and drag and let go. Say, hey, give me that as a percentage. And it's going to give default to the nearest hundredth of a percent. So Ruby pays about 0.02 of a percent per day on whatever she owes. Or she pays about 0.75 of a percent, right? 0.75 is 3/4, so not a whole percent, 0.75 of a percent each month on whatever Ruby owes. Okay. All right, so next thing I'm going to do is I'm going to add some balances in here. And let's suppose Gary has a balance of 2,500 and Ruby has a balance of, she's pretty conservative, let's go with 500. It's Ruby's current balance. And then what I want to figure out is what is the amount for a day. So above I have percentages. So down here I'm going to calculate a daily amount that she might owe. I'm going to calculate a monthly amount. And I'm going to calculate a yearly amount. The yearly amount's a little more complicated than this, but we're just going to hold it simple for now. Let's see, when we get to this in next quarter, for sure we'll get to this in Math 105. We might get to this next quarter. So here is not too bad. I just want to go equals, take the balance. Since I'm looking for a daily amount, I should go times the asterisk, the daily percentage. Now here it says it's exactly $1. That's just because it's not showing me decimals. So I'm just going to highlight all these number blocks here and say, give me 2 decimal places. So per day, if Gary's stuck at a $2,500 balance, $2,500, he's going to owe about $1.16 per day. Now, for the per month calculation, we could multiply that by 30. That would give us about that. Instead, I'm just going to go with the MPR, the monthly rate. So I'm going to take, again, because I'm using the simple interest formula, take the balance, multiply by the periodic rate. In this case, I'm going to use the monthly periodic rate. My time is just 1 month. Multiplying by 1's kind of lame, so I'm just going to skip that part and just hit enter. So it looks like he's going to owe about $35 per month. And then the yearly rate equals balance times the yearly percentage rate, the APR, enter. Now, since all the numbers pretty much line up the same way for Ruby, we could just highlight and fill those numbers over, and those should be Ruby's numbers, but I'm going to recalculate them anyway. So just make a note, it's like, you know, $3 or $4 here, 45 bucks there. So I'm going to delete those. So again, if formulas are similar, same shape, same distribution, you can highlight them, then point to the bottom corner, then click and drag, and that's like doing copy and paste, is what that's similar to. So delete. So again, equals to type of formula. I'm looking for the daily amount, so I take the balance times the daily percentage. I'm pretty sure we had 12 cents before. Equals the balance times monthly amount this time, or the monthly percentage. That gives me the monthly amount, which is about $4. And then equals the balance times the yearly rate. And I get about almost $45. So at some point today, tomorrow, or Thursday, you are going to make a similar spreadsheet for me, okay? So I'd like you to give that a try sometime today if you haven't had a chance yet, and we'll go over this again tomorrow. All right, let's get back to the worksheet. So on the worksheet, it's not the worksheet, there's the worksheet. We're going to skip on down here to Brian used a spreadsheet to record his credit card charges for the month. Brian is the guy who had bad credit, and so that means he's stuck with the 23.99%, which as a decimal is 0.2399. So what this spreadsheet says is, notice the parentheses around everything here. It says calculate the monthly percentage rate, right? Take the yearly rate, divide by 12. There's going to be a multiplication, but after all of his expenses are added up. Okay, and so yesterday Robert was asking, like, when would I want to distribute? When would I want to have it in factored form? So this is an example of a formula that's better off in factored form, I think. Add up all your expenses and then do the calculation. Okay, so that's the way most accountants do it. That's the way most banks would do it. When we're doing things like calculating perimeter and some other formulas, then we actually do the multiplication at each stage. Okay, so it just kind of depends. I told you I'd come up with a better answer today than yesterday, but I feel like I haven't. My answer is still, it depends on the situation. So I'm gonna set this up in a couple of different ways, and you're gonna try this later. And I'm mostly certain that I asked everybody for this to create a spreadsheet with the calculations for 4, 5, and 6. And so looking back here, zoom out so I can see the numbers. So 4, 5, and 6 are where we're setting up this spreadsheet right here. So I'm going to build that right now to the best of my ability. So I'm just going to add it to the sheet I've already started. And so credit card charges for the month. So let's see, this one right here is comparison. And then I need a new sheet, and we'll call this problem number 5. Now, for lack of a better name. All right, so I got credit card charges for the month. And if you don't have a computer in front of you right now, then you're going to try and double check this calculation with your calculator. And let's see what else needs to be in there. Gas, groceries, restaurant, and movie. So gas, groceries, restaurants, restaurants, I spelled that right, and movies. And then here I have to type in the amounts. So I'm going to type in my 56.08. And usually I don't type the $sign. I have the computer add that later. So I'm just going to type like this, 36.72, 12.82, and 16 exactly. And then what I can do is just highlight those numbers and say, hey, computer, please format them as currency. And so the computer will add the dollars and cents in there wherever necessary. So I'm going to do this a couple of different ways. First way is just the way they list here. I want to calculate the interest amount, or interest paid is another phrase that means the same thing. And then I want to recreate the formula that they give here. Okay. Since the percentage rate isn't already listed in the spreadsheet, I have to type it in. But otherwise, I don't want to retype any of those numbers. I just want to refer to their cells. Now, I'm not going to need to type B2 and B3. I'm just going to click on them as I go. So, oops, wrong button. Right there. So equal sign, and then just like they did, I'm going to start with the percentage. I'm going to type my 0.2399 for the percentage. Google automatically puts that 0 in front there, which is good. I didn't today. Let's see, that's going to be divided by 12 because this is a monthly rate. And there's that about 2% that we calculated earlier. Close the interest rate and then multiply by the amount of stuff, oops, times, and then start your parentheses. And then I just start clicking. Click on the gas, put your plus sign. Click on the grocery amount, click the plus sign. Click on the restaurant amount, plus sign. Click on the movies, plus sign. And Google nicely color codes that. Close the parentheses. Google will usually do that for you if you forget. Excel will not, and it will freak out on you. Sometimes it'll offer a suggestion on how to fix the formula, and sometimes it's right. So hit enter, and I believe it's $2.43 for that calculation. So those of you with calculators, adding those up, so on a calculator, I would do the following. Calculator, clear. I would take my 5608, I would add it to, so the order of operations is a little different than the spreadsheet, 36.72. Downside of typing it in a calculator, if I mistype something, I kind of got to start over, which is always a bummer, plus 12.82. So I'm kind of advocating the virtues of a spreadsheet, plus my 16. So then I get my subtotal. And then I can multiply that by the yearly rate, which is 0.2399. So that would be at the end of a year. And then I divide that by 12 or multiply by 1/12, and I should get the same number of $2.43. Okay. So you want to be the master of your calculator, whether that calculator is a spreadsheet, a handheld, the calculator on your phone, whatever you happen to use. All right, so I'm going to do this again, just for fun. A couple different ways. Let's see, I'm going to copy that into a new sheet. Number 5B. And I'm going to paste that in. So I teach Introduction to Computers, and we do spreadsheets in there. So the way I would show my students to do this is I would say, hey, make a line for the total amount of stuff. Okay, so I'm going to make a new line called total. Another word for total is sum. And so the way to add things up in a spreadsheet is to use the sum formula. So what I'm going to do is I'm going to go equals, and I'm going to start typing SUM for sum. And the computer is going to give me every formula that starts with SU. Sum a series of cells. If you're not sure what formula you want to use, then you would click, let's see, I got to zoom out so I can see all the menu items. Come on, where are you? There's an insert formula button. It's that funky looking E symbol. That's the Greek sigma. Okay. And so if I click that, it says, oh, do you want to do a sum, an average, a count, a max, or a min, or would you like to do something else? Okay, we'll explore this more later. So I could say, hey, I want to do a sum. And then it'll throw the sum formula in there for me. Zoom in. So to use it, once it throws the formula in there for me, it's just waiting for me to highlight numbers. And the way to do it is, since they're all next to each other, is just click in the first one and drag down to get all of them. And it says, oh, you want to add the number starting in B2 and ending at B5. Okay?
Is
so
this 5B or
the way. What's that?
Is 5B or 6?
I think this is part of 5B.
Because I thought 5B was the...
Oh, yeah, okay, you're right. Yeah, Lewis, yeah, Lois or Lewis is 5B. I'm sorry, this is number 6. Thank you. This is number 6 we're doing here. So the sum formula, again, there's 2 ways to use it. One way is to click and drag and collect all the cells that you want. It says start at B2. The colon means do everything from B2 to B5. So that's that whole region there. If I click back on it, it'll re-highlight that I'm looking at those regions right there. And that looks funny. Zoom in too much. That's better. Okay, so it reminds me of what I highlighted. If you ever highlight the wrong stuff, you just delete and try again. Close your parentheses, hit enter. So there's my total. So now that I know my total, right, that's my current balance, I can calculate the interest. going to call it interest amount this time, same thing as interest paid. And that's just simply take your balance and multiply by the rate. Okay, now what's my rate here? Well, I started with that 23.99%, so 0.2399 as a decimal. You can alternatively type 23.99 as long as you put the percent symbol on there. That works on most spreadsheets. Now, this isn't quite right because that's the yearly rate, so I need to adjust it by dividing by 12 to get my monthly amount. And so if I hit enter, it says, yeah, it's 243. So a slightly different way to do it. There's pros and cons of each way, okay? But anytime you have a complicated problem, there's always going to be more than one way to do it. All right, so I've gone over most of what I want to do with you. The rest, you guys can finish up on your own. So I'd recommend one of two things. Trying to write down some more answers that we didn't explicitly do together just now, or walk over into that math lab if you didn't have a computer and try building a spreadsheet for part 6 here. And let's adjust that. This is number 6, not number 5. And this is number 6 again. All right. All right, any questions before we part ways, friends in Pendleton? Okay, take silence as a no. So have a good day. I will catch up with you all soon. Get some math done. If you haven't looked at that practice test, do so as soon as possible. There's also a print version. The print version is optional. You have to do, before the exam on Thursday, you have to do this practice exam right here. And I'll change those due dates to be the 26th, but definitely get them done before then. So I recommend starting them tonight. All right, see you all later. Have a good day.
Sorry.